Hi there, Physics 152. The experiment this week is standing waves of sound inside a tube. So here is a plexiglass tube. There's a speaker at the left end, and that speaker is hooked up to a signal generator, which is called WaveTech there. And there's a switch on the back of the signal generator. You turn it on, and you can select different frequencies with the knob in the front of it. It reads off the hertz at 736 hertz, and it creates a standing wave inside the tube, which you can kind of hear. Something you should know about the signal generator is that you can select the frequency with this coarse frequency selector, but there's a fine tuning adjustment way on the back of the signal generator. You can see this little knob right here. So if you adjust the knob on the back, you can make a fine tune the frequency to within about like 10% or 5% below or 5% above the center, which you dial from here. And then inside the tube, you have this microphone on a stick. So I'll just show you, this is a stick, and at the very end of it is a microphone which is measuring the air pressure versus time. And this is connected all the way to this little amplifier. It's called the sound tube microphone amplifier. And that is connected to over here to the DAC device. And then that is connected, of course, to the computer. And so the way you access the microphone is you go to LabVIEW Shortcuts and click on Speed of Sound Tube and click on Acquire Data. And now it shows you what's going on with the microphone. So if I hit it, you get these clicks there. If I actually insert it into the tube, you can see these waves. And so what this is plotting on the computer is actually the amplitude, voltage amplitude from the microphone versus time. And this voltage is proportional to the pressure, which is being picked up by the microphone, over here. So you can see actually the microphone is inside that tube, and it's pretty near to the speaker. So the main thing that you will be reading will be the amplitude of the microphone signal on the computer screen. When the amplitude is higher in volts, then that means it's louder in here. And when you have a standing wave, you will see antinodes and nodes. Antinodes where the pressure amplitude is maximum, and nodes where the pressure amplitude is minimum. And so you can slide this along, and over here you will see there's a ruler where you can actually measure the distance. So you can calibrate it so that the distance you measure here is the distance of the actual microphone, which is at the end of that stick, from the left end of the tube. And the left end of the tube being right up against the speaker is a closed end. And the right end is a closed end if you, is either, right now it's an open end, and you can make it a closed end by inserting this, filming it very well here, but you can insert this cover, close it off there, and now that's a closed end. And so you can investigate, right now it's in closed mode, or you can open up this end and make it a closed open tube. So that's a brief introduction to the experimental part.